Lester, Wushu Engineer. I've uploaded several videos on my channel in the past dealing with the concept of the 1-inch punch and also on very short range striking. I've had a look at whether short range strikes are practically effective, what place they may occupy in a self-defense response, and analyzed them using basic impact force analysis with a load cell. Well, a lot has changed since those earlier videos addressing the 1-inch punch, not the least of which is our development of the impulse block equipment and methodology, which allows a very comprehensive analysis of most human striking characteristics. So I thought it would be a good idea to use our impulse block method to shine more of a light on some of the hidden characteristics of a 1-inch punch in order to make a more enlightened assessment of its usefulness. So we're going to try and uncover its secrets today. Short-range striking has been a part of traditional Oriental martial arts for many hundreds of years. However, it was the famous Bruce Lee who first put 1-inch punches on the map in the West, so to speak, with his demonstrations that blew many people's minds. Still to this day, many idolize him, and it's not hard to see why. He was a very gifted martial artist who was also very charismatic and also capable of presenting things in a very compelling way. Now, Wikipedia defines a 1-inch punch as follows and establishes the parameters of its use. The 1-inch punch is a punching exercise from Chinese martial arts, or Kung Fu, performed at a range of 0 to 15 centimeters, or 0 to 6 inches. The 1-inch punch was popularized by renowned actor and martial artist Bruce Lee. It's purported to improve punching power and technique. So for the purposes of this video and others, I have used the Wikipedia range parameters as the rules for a 1-inch punch. Wikipedia also mentions that the 1-inch punch is purported to improve punching power and technique. I would agree with this because one of the simple training methods used to improve performance physically and mentally, generally for just about anything, is to practice something while restricted and constrained in some way, like adopting a handicap to do something. This improves one's performance generally when the handicap is removed. A simple example of this is, for instance, lifting weights. The weights could be considered a handicap that applies resistance to a particular movement, such as a curl, for instance. Practicing the movement with a handicap makes the movement much stronger when the handicap is removed. In the same way, practicing strikes and striking while under the handicap of having very little room or range for acceleration helps to improve general striking when that handicap is removed. In addition, the Wikipedia article gives some background historical information. In this segment, it states the following: because the Southern Styles martial artists were often fighting nose-to-nose with their opponents, they had to learn a way to deal out punishing blows even while almost touching their target. I would tend to agree with that as well, noting from personal experience the very close-range fighting techniques that are almost characteristic of, or at least one of the characteristic features of Southern Kung Fu fighting styles and systems. However, I would go so far as to say that close-range fighting is and always has been an important component of any kind of self-defense and or combat training, whether it was practiced in the West or in the East. Aggressive and physically powerful, dominant attackers will often attempt to close down their victims, overwhelm them with close-in striking or grappling, limit their range of movement, limit their ability to move, closing them down, shutting them down. Whether it happens in trench warfare, urban building clearing, or defending oneself against stronger opponents in a simple civilian setting, very close combat fighting skill is crucial. Even heavily armored knights in days of yore would find themselves locked in grappling situations and defending themselves against opponents seeking to avail themselves of the weak spots in their armor. In very close combat situations, being able to strike effectively without requiring much space or range broadens a defender's portfolio of options and makes them much more likely to be able to weather the situation. A common scenario encountered in self-defense situations involves being dragged or knocked to the ground and having to grapple and fight from the ground. Ground fighting limits one's ability to accelerate punches due to the inherent restrictions to mobility and range associated with this claustrophobic environment, and due to the fact that a lot of the power for a conventional standing striking and kicking comes from the fact that the person is standing and moving on their legs. So the legs add a large component to that power. Often in ground fighting scenarios, many fighters default almost solely to grappling, which limits their portfolio of techniques and can also leave physically weaker defenders very vulnerable to stronger opponents unless their grappling technique is flawless. In this restricted environment, having a working knowledge of how to strike powerfully and effectively, such as can be learned from practicing restricted range striking and kicking, can make all the difference and can significantly expand a fighter's portfolio. There are also other benefits to being able to strike effectively from close range. These include speed of application. In other words, striking without the need for any kind of wind-up that would introduce an additional time cost, as well as short-range striking being often less predictable and less expected than conventional long-range strikes. So there's less likelihood of telegraphing your intention with much shorter range strikes, potentially. Now, I typically tell my students that a portfolio of fighting techniques needs to be a bit like a Swiss Army knife. It should not just contain one or two tools, it should contain a bunch. Your knowledge needs to be broad enough to allow your response to be able to adapt to whatever situation you might find yourself in. So on to the big question: how well can a 1-inch punch work in an actual fight or combat situation? Let me first state flat out that short-range striking is not a preferred option, certainly not my preferred option. If I had the range and the space, I would absolutely be accelerating strikes over much longer distances, obviously to gain more kinetic energy, more power, etc., etc. But short-range striking is a valid tool in a portfolio, and it might be appropriate under certain conditions, such as some of the conditions I've already mentioned, being closed down, not having space, etc. Here in this video, I'm going to perform various tests and demonstrations to provide sufficient information for my viewers to make their own minds up about whether or not short-range striking is effective. I will stress at this point that all of the tests performed in this video were performed essentially under optimal conditions and not under the stress of a real combat situation, obviously. This should be considered one of the test limitations. Although adrenaline secretion and the fight response would improve my physical performance somewhat during, perhaps depending on the level of stress and the amount of adrenaline dumped into my system, it could improve my physical performance a little bit or a massive amount. Although that happens, suboptimal positioning, opponent intervention, and timing restrictions may simultaneously act to decrease my performance. So it's a give and take. It's hard to actually make a direct comparison to a real situation. I might have a brief discussion here about some of the equipment we're going to be using. In addition to the impulse block equipment and method, we also have access to a PowerKube 2 device, which we have used in some of our past videos. The PowerKube 2 device uses an accelerometer to extrapolate the energy and power of a strike and provides an output using a proprietary compound unit called the Franklin. Up until a couple of years ago, the PowerKube website included a chart called the Scale of Human Force, showing various striking records. They've taken it down from their website, but I have retained a copy of it, which I'll show you here. As you can see, the record for a 1-inch punch at the time that the table was compiled was 4,000 franklins, which is actually only 1,000 franklins below the maximal strike that might be expected from a typical untrained male. The scale of human force table states that rules apply for the 1-inch punch, but does not elaborate on what those rules are. So I've included a compilation of my 1-inch punches against the PowerKube. As you can see, my best performances are typically above 3,000 franklins. In fact, in one of the strikes, I managed to beat the stated 1-inch punch record with a value of 4,181 franklins. However, as the rules applied to that particular record are uncertain, I won't make any bold claims in this video, apart from stating that I may have broken the record. You will note from the video clips that I do pull back slightly before delivering the strike. So my fist actually does shift back slightly before I strike. Although my body is committed to the strike, you'll notice that my fist lags slightly and then connects with the target. However, in all cases, I have drawn back to a striking range of less than 15 centimeters, which is in accordance with the Wikipedia parameters for a 1-inch punch mentioned earlier in the video. Here is a compilation of some of those strikes against the PowerKube slowed down and calibrated to show the drawback distance. The first in this compilation is the potential record-breaking 1-inch punch. I also performed a set of 1-inch punches against the impulse block. My apologies if you've heard all of this before. I have to kind of go through the details of what the impulse block methodology is in each of the videos that I use it, so that new viewers can understand where we're coming from. But the impulse block method allows for one of the most comprehensive methods of analysis of human striking available currently to our knowledge. Our impulse block method is currently being independently tested for validity and reliability as part of a study by another researcher from the University of Southern Queensland. In a nutshell, the impulse block equipment consists of a specially designed foam spring called the impulse block attached to the front face of a load cell that records force input at a sampling rate of approximately 1 kilohertz, along with a laser photogate timer of my design that allows the measurement of time of flight in microseconds across a 1 centimeter gap just prior to impact with the impulse block. Using the measured values from the force time data plot produced by the load cell, along with the time of flight of the impacting object just prior to impact, it becomes possible to calculate a number of characteristics associated with that impacting object. These characteristics include impulse or change in momentum imparted by the strike, impact velocity, peak filtered impact force, predicted impact surface dependent impact force, kinetic energy of the impact, power of the impact, and apparent or effective mass behind the strike. Please note that apparent or effective mass is not simply the mass of the weapon or part of my body involved in the strike. It's calculated from the impulse value and is actually that part of the mass of my whole human system that is involved in that impact. For a more detailed explanation of the impulse block equipment and methodology, see my other videos on the topic. In some of my previous videos involving the impulse block method, we have shown only half the total impulse value on our tables because that is what is used to calculate other values such as kinetic energy, apparent mass, and power. As such, when we compare the results obtained in this video to any of our previous results, we will provide both the half impulse values and the full impulse values for easy comparison. I should also briefly explain the concept of peak equivalent impact force, which is a new characteristic that we're introducing into the suite of impact characteristics calculated using the impulse block method. Peak equivalent impact force is simply a predicted force peak calculated based on fitting the impulse data into the typical force time curve of a 7 kilogram medicine ball impacting the load cell from a height of 1 meter with a thin EVA foam mat placed on the load cell front plate. As I've explained in previous videos, the impact force is very dependent on the physical characteristics of both the impacting object and the surface that that object impacts. Soft objects of a particular weight traveling at a certain velocity impacting on soft surfaces will yield relatively low peak impact forces with relatively long impact durations, whereas hard objects of identical weight and impact velocity impacting hard surfaces will generate much higher peak impact forces with much shorter impact durations. In both cases, the impulse will be identical, but in the case of the hard objects striking the hard surface, the impulse will be squashed into a narrower impact peak with a higher peak force and a shorter impact duration. Please note that peak equivalent impact force value that we are introducing is not a direct measure of impact force on the load cell. It is calculated by fitting impulse data into a characteristic impact peak. So direct comparisons can't be made between the peak equivalent impact force values presented here and simple load cell force outputs, unless the same mathematical operations are performed on the raw load cell data. So basically this new characteristic that we are introducing is not actually relevant yet, but we're hoping that it will eventually get adopted as an industry standard method of reporting impact force, because currently it is essentially impossible to compare force values from impact-based measurements from one study to another without ensuring that absolutely identical equipment and conditions were used in both tests. And that makes the unit of impact force kind of irrelevant even in and of its own self, because direct comparisons can't really be made. However, introducing a standardized approach in this new value that we're introducing might allow direct comparisons to be made between peak equivalent impact forces reported in different studies, as long as they applied the exact same method to calculating the values. No scientific test would be complete without mentioning the sources of error. Although it's not typically considered a source of error in sports science, my natural human performance variation far eclipses typically the scale of variation and error introduced by other sources. Relative to my natural human performance variation, the scale of equipment measurement error is so small typically that it can safely be ignored. Nevertheless, it should be noted that due to harmonic distortion and harmonic losses in the load cell and impulse block equipment, there is an error associated with the calculation of impulse that typically ranges between 1 and 10% of the expected value. Lastly, we must acknowledge that a very small sample size was used. The small sample size can lead to errors. You will also note from the video footage of the tests on the impulse block that I used a piece of masking tape as a spacer on the impulse block to ensure that I didn't accidentally activate the laser photogate timer prematurely. Otherwise it would have invalidated the test. And this is what the impulse block tests looked like.
Okay.
Ready?
Yep. Okay, it's ready?
Okay.
Ready? Okay.
Once I completed the tests, the Wushu scientist performed a numerical analysis of my results, and this is what my average 1-inch punch performance looks like. These values, although lower than those associated with my full range striking, are still higher than many people would expect from such a short range strike. But can we compare these results with the average performance of a group of other people? Well, indeed we can. We actually have the data, and so we can make a comparison. As I mentioned previously, the impulse block method is currently being independently tested by another researcher from the University of Southern Queensland. And part of that study has involved accumulating striking data from a range of participants that included people with significant martial arts experience and also people with little to no martial arts experience. The strikes performed by the participants in this test were flat palm strikes. So flat palm strikes performed from a stationary stance of their choosing and using full range of movement, or full range of motion. In other words, the range of the strikes was not restricted aside from the restriction inherent in the stationary stance. And this is what the average performance of the participants looked like. As you can see from comparing the values on my table with the averages presented from the participants in the tests, with the exception of impact velocity, all other characteristics of my 1-inch punch were actually significantly higher than the average striking performance. In fact, my impulse value was nearly twice the average. As could be expected, my impact velocity was slightly lower than the average because I have such a limited range over which to accelerate the strike. However, my ability to more than double my apparent mass in a 1-inch punch as compared to the average performance of the test participants lifted all other characteristics, such as kinetic energy. This made my 1-inch punch more effective than the average full range striking performance of the test participants. But that's all very well and good, I hear you say. This is like an average. It's a cross-section of people that include experienced martial artists and people with very little experience. So what about the best average characteristics displayed amongst all the participants in the test group? It's a bit of an unfair comparison to make because you might find someone, for instance, who can strike with a high impact velocity but without much impulse behind the strike. Likewise, you might find someone who can strike with high apparent mass but cannot strike with sufficient impact velocity to yield a high kinetic energy. As a single participant, I would then be comparing my average values against the best average values achieved by a whole group of people. So for what it's worth, as unfair as the comparison may be, here it is. From this you can see that all but one of my 1-inch punch average values were beaten. My average apparent mass was still higher than the best average though, by nearly 1 kilogram. However, Despite the fact that most of my average values were lower, there was a surprisingly small difference between them. There was less than 2 Newton seconds difference between my impulse, the impulse of my 1-inch punch, and the highest average impulse generated by the group. It must be said that the best average velocity in the group was significantly higher than the average impact velocity of my 1-inch punch by nearly 2 meters per second. The best average kinetic energy and power were also higher, but not by as much as one might think. As you can see, my apparent mass managed to pull my kinetic energy and my kinetic energy up a little bit, which of course fed into the power as well, although my impact duration was longer. I hope that you can see from this data that despite its extreme restrictions, the striking characteristics of a trained 1-inch punch can compete effectively against those of full-range strikes. Although it would not be my first choice in terms of self-defense, it may be the only choice that's available due to circumstances. In addition, training such short-range striking can help to improve full-range striking characteristics as well. The 1-inch punch should not be considered merely a curiosity, nor should it be relegated to idle party tricks. It's actually a very powerful training tool. It's well worth the training overheads to develop this kind of striking. Well, I hope you enjoyed this video. I hope you found it informative and interesting, and I'll see you all again next time. Thanks for listening to the end of the video. Cheers.